Assalamualaikum warahmatullahi wabarakatuh. So my team consists of 4 members and my name is NATASHA binti Muhammad SUHAIMI. My metric numbers is 2022471448.
And my name is MASTURINA binti ROSLI and my metric number is 2022812314.
My name is FARRYN binti ABDULLAH and my matrix ID is 2022469206.
Assalamualaikum, my name is AZIZ bin ZAINAL. My matrix number is 2022497268.
So what is proof? A statement is considered as a sentence or proposition that will be either true or false, or a convincing argument that can be expressed in mathematics. So in doing proof, you need to identify the hypothesis and the conclusion in the sentence given. So what is hypothesis? Hypothesis is the sentence that is assumed to be true, while conclusion is a statement that needs to be proved. So next is the example of the statement. If n is an odd number, then n power of 2 is an odd number. So the hypothesis is n is an odd number, while the conclusion is n power of 2 is an odd number. So how to prove that A implies B? By using forward-backward method. In the forward-backward method, it is important to identify the hypothesis and conclusion statement first to reach the conclusion that conclusion is true. Then, you need to throw several clear and logical arguments to reach the conclusion. In the forward-backward method, we will use several terms such as A1, A2, A3 and B1. These terms will define each argument that we use to prove the statement A implies B. B or B1 defines the sentence that needs to be shown to be true. This step is included in the backward process. To show that B or B1 sentence to be true, we will use the forward process which contains A1, A2 and A3 and use any logical arguments or general knowledge to reach the conclusion such as factorization, subtraction or substitution method. This whole process can also be called analysis of proof. After reaching the conclusion, we must write the condensed proof. Condensed proof is a written paragraph to show how we reach the conclusion by using any logical arguments or general knowledge. For example, by using the substitution method, substitute A1 in A2 into A3 to obtain A4, or factorize the number 2 of the function. To conclude, the condensed proof is to conclude all the logical arguments or general knowledge that we go through to reach the conclusion or to show that the conclusion is true. Last but not least, the small box at the end of the proof is to show that the proof is completed.
Okay, next we go to example 1. If m is an even integer and n is odd integer, then m plus n is odd. For solution, first we will do analysis of proof, which is we divide the question, become hypothesis and conclusion. So m is an even integer and n is odd integer will be the hypothesis, and m plus n is odd will be conclusion. Next we will do backward process, which is from the conclusion, then we'll get b1 equal to m plus n equal to 2p plus 1 for some integer p, which is 2p plus 1 is the definition of odd integer, because m plus n at the question is odd, so we need to use the definition of odd integer. Next we do forward process, which is we take it from the hypothesis that we do in analysis of proof. So A1, m equal to 2k for some integer k, because of m is an even integer, so we use definition of even integer. And A2, n equal to 2t plus 1 for some integer t, because of n is odd integer, so we use definition of odd integer. And A3, m plus n equal to 2k plus 2t plus 1 because we substitute a1 and a2 into m plus n. And a4, we simplify a3, which is m plus n equal to 2 in bracket k plus t and plus 1. So we will get 2p plus 1 where p is k plus t, which is 2p plus 1 is equal to the definition of odd integer. So from the A4, we know that A4 is same as B1. For condensed proof, we know from the hypothesis M is an even and N is odd. Then M equal to 2k and N equal to 2t plus 1 for some integer k and t. So M plus N equal to 2k plus 2t plus 1, and we simplify it, become 2p plus 1 for some integer p, which is p equal to k plus t. And then we can prove it that m plus n is an odd integer because of 2p plus 1.
Okay, given a triangle PQR with PX is perpendicular bisected, QR and the length of PQ is twice the length of QX, show that the triangle PQR is equilateral. To understand more about the question, you must draw the triangle of PQR to identify the analysis of proof, which is you must find the hypothesis and also in conclusion. So in this kind of question, A, the one that I highlighted with the purple one, is the hypothesis, and B is the one that I highlighted with the pink one is the conclusion. So in backwards process, you must use the conclusion B1, which is PQ is equal to QR is equal to PR, by using a definition of equilateral triangle. And then we go forward to forward process, which is A1, QX is equal to XR. PX is perpendicular bisector of QR. Then for A2, it says that angle QXP is equal to angle RXP. The angle is 90 degree, which is a right triangle. And then for the A3, it says that PQ square equals to PX square
Plus 2.
QX square, which is we can say that this is the structure of Pythagorean theorem. And then A4, same goes, and then same goes as A4, it is a Pythagorean too. And A5, PR square equals to PX square plus QX square. It substitute from QX to XR. And then A6, PQ square equals to PR square, which is same as A3 and A5. Alright. Then for A7, it says that PQ is equal to PR. It's simplified from the A6. And A8, PQ is equal to 2QX, which is the hypothesis number 2. The hypothesis number 1 is this one, right? So the hypothesis of number 2 is from A8. And then A9, QR equal to 2XR, which is same fact as A8. And then A10, QR is equal to 2QX, which is we substitute QX into XR. And then we go to A11, PQ is equal to QR, which is same as A8 and A10. Same goes A12, PQ is equal to QR is equal to PR, which is A7 is equal to A11. And then by having A12, we can say that A12 is equivalent to B1. There is. Alright, for the last one is condensed proof. From the hypothesis, PX is perpendicular bisector of QR and the length of PQ is twice the length of QX. By using Pythagorean theorem, PQ square equals to PX square plus QX square, and PR square equals to PX square plus XR square, obtain PQ equals to PR. By hypothesis number 2, PQ is equal to 2QX and QR is equal to 2XR. That will obtain PQ equals to QR equals to PR. Therefore, the triangle PQR is equilateral.
Example 3. If S and T are two consecutive odd integers, then 2 divides S squared plus T squared. For first step, we use analysis proof to identify the hypothesis and conclusion. A. S and T are two consecutive odd integer as hypothesis. B. 2 divide S squared plus T squared as conclusion. Second step is we use backward process. By using definition of divisibility, we get B1 2 divide S squared plus T squared. It will be S squared plus T squared equal to K for some integer case. After that, we use forward process. By definition of odd integers, for A1, S equal to A plus 1, T equal to 2A plus 3 for some integer A. By using substitution method, substitute A1 into the equation S squared plus T squared. We get for A2, S squared plus T squared equal to 2A plus 1 square plus 2A plus 3 square. We get 2 open bracket 4A square plus 8A plus 5 close bracket. Thus, we get 2K where K equal 4A square plus 8A plus 5. Therefore, A square is equivalent to B1. Lastly, condensed proof. So, the answer is given that S and T are consecutive odd integer. Since S and T are odd, then it will be existing an integer A such that S equals to A plus 1 and T equal to A plus 3. Therefore, S square plus T square equal to A plus 1 square plus 2A plus 3 square. Then is its integer K, which is S square plus T square equal to 2K, where K equal to 4A square plus 8A plus 5.
Last but not least, the conclusion. The forward-backward approach is the most fundamental way to generate a proof. Your goal is to lay out the proofs and create a logical path from what you are given A and what you are attempting to prove, which is B. When to use it, as first attempt or when B does not have reasonable form, what to assume A, what to conclude B, and how you do it. Work forward using the facts given in A and apply the backward process to B by asking how or when can I conclude that the statement B is true.